So we need a free body diagram, they say, on this block, first of all. It's just being pulled straight to the right. They tell us that with a force F. I'm actually going to call it FA for force applied, just to be a little bit clearer. We know that we're going to have gravity on it, so I'll label that F sub G here. We know that it's not accelerating up or down, so it must have a force to counteract gravity. Let's call that normal up. This should be the same length as that if they make you draw relative sizes. And it said in the description up above that it was going a constant speed. And that's really important because that lets you know that all the forces have to balance. And so there has to be a force back just as far, and this is the force of friction here. So that's what your free body diagram should look like. So now on to the problems of it. It says in part B here, so the free body diagram is part A. So in part B, calculate the force exerted by the rope that keeps the box moving with a constant speed. Well, just like we just said, we know that the sum of the forces, applied Newton's law, in the x direction is equal to mass times acceleration in the x direction. And this is what let us figure out before, that since this is equal to 0, the acceleration, then the net force must be equal to 0. So we can say that the force applied to the right minus the force of friction back the other direction has to be equal to 0. In other words, the force applied is equal to the force of friction. So all we need to do now really is find the force of friction. So how do we find the force of friction? Well, there's an equation that says it is mu times the normal force here. So now we just need to know what the normal force is. Now it seems pretty clear here, we've said it many cases before, that the normal force is equal to the weight. And you're probably okay in just jumping right there. But just so we can emphasize why, let's do another Newton's second law. The sum of the forces in the y direction is equal to the mass times the acceleration in the y. This is also equal to 0 because it's not accelerating vertically. So that means that our normal force up minus our force of gravity down has to be equal to 0 as well. And so in other words, the normal force is just equal to the force of gravity, which is just its mass times gravity. So we can actually just substitute that in for the normal force right here. So we can say the force of friction is equal to mu times mass times gravity, and now we can just plug in numbers. They say the coefficient of kinetic friction is 0.4, and that the mass there is 10 kilograms, and that the gravity is 10 meters per second squared. And so that's 100 times 0.4 gives you 40 newtons. Technically what we solved for here was the friction force, but the friction force has to be equal to the force applied in order to move it at a constant velocity there. So now they say, what if instead we pull with 100 newtons at an angle of 37 degrees? What will be the normal force now? So we've got some vectors here. So just to clarify, we're going to pull here with 100 newtons at an angle of 37 degrees. So we're going to have to find some components. So for example, we have a component right here. If we call this overall component still FA, like that, then we can call this component right here FAX. And we can solve for it pretty easily. It's going to be equal to FA times the cosine of the angle. So we can solve for it that way. We just plug in here 100 times the cosine of 37. Cosine of 37 is roughly 0.8, so you multiply that by 100 and you get FAX equal to 80 newtons basically. Then we got to find the vertical component here. So FAY we can call it, that's going to be equal to FA times the sine of the angle there. And so if we plug in some numbers from here, we get 100 times sine of 37. And so sine of 37 is roughly 0.6. So this is going to give you about 60 newtons here for FAY. So what is the normal force actually? Well, that's just going to involve this part right here. We can say again, just like before, that the sum of the forces in the y direction is equal to mass times acceleration in the y direction. There is no acceleration in the y direction, so that's got to be equal to 0, so the sum of the forces has to be equal to 0. What are the forces? Well, we have the normal force up, plus the force applied in the y direction up, minus the force of gravity down. So rearrange to solve for the normal force. So we get the normal force is equal to the weight minus the force applied in the y direction. And we already have numbers for all of these. We already know that it has a weight of 100 newtons. We just solved that the force applied in the y direction is 60 newtons. And then we get that the normal force in this case is 40 newtons. Now, the previous answer was 40 newtons too, but I don't want you to think that, oh, this is 40 newtons, so this always is 40 newtons too. That doesn't have to be the case at all. They just are in this one. So the force applied is 40 newtons. So now they say, what is the force of friction on the box? Well, this one is pretty straightforward because we know that the force of friction is the coefficient of friction times the normal force. And they gave us this. It's 0.4, and we just solved for the normal force. It is 40 newtons. So right now, our normal force then is 16 newtons. Or sorry, our force of friction is 16 newtons. So that one was pretty easy. Last step here then is to solve for the acceleration of the box. That is going to be in the x direction there. So it's an x question. So once again, Newton's law, the sum of the forces in the x direction is mass times acceleration in the x direction. I'm going to go ahead and rearrange and say the acceleration in the x direction is the sum of the forces in the x direction over the mass. Well, what forces do we have in the x direction? We've got the force applied, but it's not the full force applied. It's just the force applied in the x direction there. And we got the force of friction back the other way. All of that over the mass. And we've actually just solved for all of these already. We know what they are. The force applied in the x direction we solved on the previous one was 80 newtons. And the force of friction we just solved for was 16 newtons. And so now we can take that and divide it by the mass, which was 10 kilograms. So 80 minus 16 is a total of 64 newtons over 10 kilograms. So we get the acceleration in the x direction is 6.4 meters per second squared.